Welcome back to Math in the Bubble with your host, Mr. Daly. Today is, in fact, the last episode because we're going to be moving out of lockdown next week, and also I've been told to not do any more teaching. I've been sent this email, so I'll just show you that. This is the main important thing for you guys. If the announcement is made on Monday to move to alert level 2 next week, then the expectation is that it will be a week of consolidation teaching and learning. Nothing new should be posted for students or staff to engage with. This will be a time for teachers and students to catch up before the return to school. Okay, so because I've been sent this message, I've just decided this is going to be the last video that I'm going to make, but I'm going to host some Zoom meetings during the same time slots on Wednesday and Friday. Does that mean no work? William asks. Basically, no work. Well, you if you've kept up so far, then yeah, there'll be no new work for you to do. I still haven't seen everyone's 3D solids, so that's maybe something you could do. Anyway, back to my Droid cam. Yeah, so Wednesday and Friday we're going to post a link to Schoology, and that'll be in the This Week folder. So Margot just asked if we go back to school, can we do a refresh over everything? Absolutely. I'm pretty sure there will be some students who just haven't seen any of these videos and will need to pay absolute maximum attention for the first week. But I'm probably just going to do some recaps. But it will be quite quick because we are quite far behind because I've been slowing us down and sort of spreading out the content. Anyway. Hey Hugh. This is probably the best stream though, out of everyone. The most of the classes turning up. I've got 2 Year 9 classes and we get about the same amount. So you guys are doing well. You guys are my new favorites, in fact. Before lockdown, maybe not so much. But now, definitely. Alright. Okay, let's get started. Got some simple questions to do today. We have, if you can do this at home, if you measure a juice box, like a Just Juice, the 1 litre ones, then you get these sort of measurements. It would be close to these. It might be 16.3 or whatever. But I just wanted to show you something that you can do at home. It's really pretty cool. So to work out the volume of this shape, it's pretty simple. It's just going to be our width times our length times our height. So 7 times 9 times 16. 7 times 9 times 16. Let's just plop a calculator on there and see what we get. 7 times 9 times 16 gets you 1008 centimeters cubed. And why is this an impressive number to have gotten? Well, that is approximately 1000 centimeters cubed, if you were to round to one significant figure. well, actually, if you rounded to two significant figures, it would be that. But anyway, that thing that I mentioned in a previous episode is that a centimeter, 1 centimeter cubed, so you could imagine measuring 1 little centimeter cubed, is equivalent to 1 mil. So really we have 1,000 mils, and what am I doing? 1,000 mils equals 1 litre. Said an aneurysm, I think. Yeah, so by measuring it, you can really prove to yourself that centimeters are mils. So that might be an interesting thing that you could do at home. And if you unfold this juice box, how much area would you get? Well, let's think about that. We're going to have 6 sides when we fold it out, because it's like a cube. There's going to be surface area. It's going to have 2 times side 1, 2 times number 1. Look, I'm going to scroll up a bit. So surface area is going to have 2 times side 1. We've got this front and back, and top and bottom. So there's going to be 2 plus 2 times side 2 plus 2 times side 3, tops and bottoms. Okay, so if we unfolded our juice box, we would get side 1 is 9 by 16, 2 times 9 centimeters times 16 centimeters, plus 2 times side 2, which is 7 centimeters times 16 centimeters, plus 2 times side 3, which is 7 by 9 times 7 centimeters by 9 centimeters. Okay, so we can put this all into the calculator. Two times 9 times 16. I'm going to put this all in one row. 2 times 7 times 16 plus 2 times 7 times 9. 638. What will our units be? Well, area, units are square centimeters. I wonder if that would be similar to an A4 sheet of paper. Because an A4 sheet of paper is 29.7 centimeters by 21.0 centimeters, just off the top of my head. I've measured them many times. 21 times 29.7. Wow, it's actually really close. Isn't that interesting? 623.7. So what that's basically saying is, if you fold up an A4 paper, then you can contain almost 1 litre. I'm sure if you made a perfect rectangle, yellow square, that'd be the best way to do that. I never thought about that before. I was just thinking. Wow was right, William. Wow is right. Alright, uh, so while I'm on the subject of measuring things, I was thinking of something that you guys could do at home. Well, you guys might not be able to drink craft beer, but you can measure it, and that's okay to do. Just tell your dad that, or your mum, she might be into craft beer as well, that it's a Mr. Daly measurement task. So what we want to do is we want to measure the volume. I also chose this can because it's a really cool can. That's the thing with craft beers, they have the best art on them. So where does it say the mils? Most cans are 330 mils. So what we want to do is measure these dimensions of this can and see if we can, which we're going to assume is a cylinder, even though it's got this tapered bit at the top and bottom. We're just going to assume it's basically a we're going to assume that the cylinder cuts off those little bits. So when we get our final answer, we might get slightly over 330, but that's because of those little tapered bits. Yeah, well, that'd be an interesting thing, Eamon, to work out how much volume is in one mouthful. Maybe we'll do that as an experiment when we get back with soda. Soda? Okay, so what I've got here is tape measure, which is good for measuring cans. The best measurement to get from a can is around the side. So, oh, that's nice. It's right on 21 centimeters. See that? So what we've measured here is the circumference of our can. And using that circumference, so what we've just measured here is, I'll just draw it, from here all the way around to the start again of the can, the circumference equals 21 centimeters. Alright, now I might just try and get this whole thing on the shot. Look at that design on that can. And just a little bit up. Oh, this is this is really hard to do. So I'm gonna say, let's just say 110 centimeters tall. So we got 110 centimeters. No, not centimeters, millimeters. Doi. So 11 centimeters. Okay, so to work out the volume of your dad's fancy craft beers, you need the radius, because we need to work out this top area and then multiply it by 11. We can get the radius from the circumference, because we know that the circumference equals 2 times pi times r. So if we have circumference, then we have these two. We know what 2 is. 2 is 2. Pi is 3.14. So we can figure out what radius is by dividing by 2 pi both sides. What happens to those 2 pi? Those are gone. So we're left with a new formula that is C over 2 pi equals our radius. And our radius was 21. So 21, oops, I've done this we'll just have to scooch up a bit. So circumference is 21. 21 divided by 2 pi equals our radius. So let's just chuck those numbers into the calculator. 21 divided by 2. Okay, I'll just explain that again, Leilani. Alright, so we got a radius of 3.34 centimeters. Okay, so Leilani, I just wanted to explain why you divide it. So the regular formula for circumference is 2. Circumference is equal to 2 times pi times r. Right? So what we want to know is radius. So we want a formula that looks like this. Oh yeah, true. That's right, Eamon. There's an extra 2 in there for SF. So if we want to make r the subject of the formula, so that means that we want to get all the other things on the other side of the equals. So if these are multiplied by r, so to get it away, what I did over here is I divided by 2 pi on both sides, and the reason I did that was because that would get rid of the 2 pi on this side, because 2 divided by 2 is 1, pi divided by pi is 1, so really you've only got r left, and then your formula now becomes, so c equals 2 pi r, and c over 2 pi equals r. These are the same formula, but they've been rearranged, right? So in this one, r is the subject because it's by itself, and this one, c is the subject because it's by itself. Okay, back to it. We have found the radius. Now that we know the radius, we can find the volume, because the volume of any prism, of a prism or a cylinder or a rectangular prism or a triangular prism, is just our area of the face, so the top of the can, times the length. So we can replace the area for the face with an area of a circle, pi r squared, times it by length. So we have our radius, that was 3.342, and our height was 11 centimeters. Remember that up here. So we want to go pi times, I'll just put it in bracket to show that I'm inserting a number, 3.342 squared times by 11. So that was a length, or the height. So just get all this in the same thing. Shift pi times, put all the brackets in, 3.342. You don't really need all these brackets, I'm just sort of showing our radius has been inserted in the brackets, times 11. So we got 385 0.9 or 7. So how far off were we? We were pretty far off that time, eh? I think you could actually attribute a lot of volume to this little bit that's been cut off. You could probably assume it's a little triangle there. Yeah, and also there may not actually be there's probably an air gap in the can as well, so that'd probably add a little bit extra. So approximately 330 mils. I mean, it's within the ballpark. That's ballpark accuracy right there. Yeah. So you could say minus the taper would be, and minus the air gap inside, because they'll have an air gap so that they can get their gas for the carbonation in there. So really, when you I mean, you think of a bottle of Coke, they never fill it all the way up to the top, do they? There's that air gap, or carbon dioxide to give it gas. Alright, next thing, we're going to do some algebra. Because we're probably going to do a lot of algebra tests, like back to back, like almost one every day when we get back, just to get them out of the way. And I'm pretty sure William just said, it's like when the bag of chips is always half filled. That's exactly right, William. So it might have looked like our answer was horrible, but it's actually not too horrible. Alright, back to it. So we haven't done a lot of these x's both sides problems, so I'm just going to do a few just to wrap up the episode, and then we'll just, maybe there's some problems that you can suggest that we do, because we've actually got quite a bit of time left. Alright, so for a start, with x's both sides, that's right, Amelia. Anyway, I always go x's left, numbers right, even if I get a negative on my x term on the left and a negative on my numbers on the right. You can always it doesn't matter which side you put your x's on, or your numbers, but generally it just looks nicer if you do it this way. So you really only do it this way because it's just going to look better at the end. But there's lots of ways of doing it. Anyway, I always just put a tick above the terms that are in the right spot. So our 5x is in the right spot. Our 27 is not, because it's supposed to be on the right, numbers right. And our 2x is also in the wrong spot because it's x is left. Alright, so that means that we need to get rid of the positive 27. To do that, we need a negative 27. And when you do something to one side of the equals, you do it to the other side. So we'll put a negative 27 over here. You could imagine there's a 0 there. Sometimes there's no number on one side, but that shouldn't trip you up. With the 2x, we need a negative 2x to cancel that out, and because we had a negative 2x on this side, we're going to have a negative 2x on this side. Right, now it becomes pretty easy. 5x minus 2x is 3x. 27 minus 27, those are gone. Those cancel it out. 2x minus 2x, those are gone. So we've still got our equal sign, it's still there. 0 minus 27 is going to be minus 27. Now to find out what x is, we simply divide by 3 both sides. And we're going to get x equals negative 9. Capiche? Okay. Number 2. X is left, numbers right, so put some ticks up there. That's in the right spot. Numbers, that should be on the right, so that's in the wrong spot. That number is in the right spot, so on the right. That X is in the wrong spot, so on the left. That should be on the left. Okay, so we're going to get rid of the 19. It's in the wrong spot. Negative 19. Pair up a negative 19 over here with that 83. And then we want to get rid of our 17x, so we're going to take away 17x both sides. It's going to leave us with 3x. 19's cancel out. 17's cancel out. 19x equals, what's that going to be? Negative 102. Yeah, COVID minus 19. Is that going to be the new number that everyone whispers under the grate? COVID-19. Every time Mr. Daly uses that number. Anyway, back to this. Divide by 3 both sides. X equals, you don't always divide by 3, it just happens that we end up with 3x both times, so it's just, this could be a 4x and you divide by 4. Doi. 102 divided by 3, quick math, negative 34. Alright. Yeah, I didn't want to say that on the chat though, William. Obviously, for obvious reasons. Alright, maybe I'll try and make a question where the answer is 19 for you guys to just do by yourselves to make sure you got the hang of it. Alright, so this might take me a minute. So we're going to have a all good, Indy. This is the last episode ever, by the way, so you'll have to check the video tomorrow for updates. There's a lot of updates. Alright, that should be the most fun X's both sides question that you've ever done in your life. So have a go at that. I'll give you 2 minutes. Alright, get a balloon. Alright, let's do this most interesting math. Oh, you already done this in science. Damn science, taking all the good problems. Alright, so 9's on the right side. 123 is not. Negative 10's not. 484 is. So We want to get rid of the 123 by subtracting 123 both sides. We want to get rid of the 10x by adding 10x both sides. That's going to leave us with COVID-19x. There's going to be nothing there, and nothing there, and this is going to be 361. So 19x equals 361. COVID-19x equals 361. And if you divide by COVID-19 on both sides, then that means that your answer will in fact be COVID-19.